Good morning. In this next video, I'm going to consider exercise 113, which is to be found on page 38. Once again, this exercise is a typical optimization problem involving the graph of a function. We are considering the following function here, f of x equals 3 minus x squared. Here you see a picture of the graph of that function here. So what do we have? We have a point uv on the graph of f, and we assume that the x-coordinate u of point P is bigger than 0. So this point here lies maybe, let's say, here. What else? We consider now the tangent through that point like this. So this is the tangent through point P, and as you see here, this tangent defines, together with the coordinate axis, it defines a triangle like this. And what do we want? We want the area of that triangle to be maximal. Okay, so let's say this point here is R, and let's say this point here is Q. Then the area of triangle, and this here is of course O, then the area of triangle ORQ should be maximal. So this is our problem. Now, before we start with anything, let us quickly see how we are going to calculate the area of that triangle. The area of the triangle is given by, well, look at it, it is a right-angled triangle, so we can take side times side divided by 2. So the area of the triangle is given by OR times OQ divided by 2. Okay, so this is the formula of the area. In the next step, we are doing what we were always doing when considering such exercises. We introduce coordinates. Okay, so point R, well, point R lies on the x-axis, which means the y-coordinate is 0. So let's say point R has coordinates x1, 0. Point Q lies on the y-axis, so the x-coordinate is 0, and let's say the y-coordinate is y1. Okay? And now here's the first important thing to realize. If R has coordinates x1, 0, and Q coordinates 0, y1, well then OR here, which is here, is x1, and OQ, which is here, is precisely y1. So the area of the triangle is in fact given by x1 times y1 divided by 2. Well, if you consider this here, what are we going to need? Well, we need, of course, we need a relation between x1 and y1. How are we getting this relation? Well, what do we know about points R and Q? Well, we know one single thing, namely they lie on T. R and Q lie on the tangent. So this is what we are going to use in order to get the relation between x1 and y1 we need. Okay, so of course, the only thing we know about R and Q is that they lie on the tangent, so we need the equation of the tangent. Let's see. Tangent, linear function, given by an equation like this. Now the first thing is the slope of the tangent is given by the derivative. So the slope of the tangent is given by f prime of u, which is just minus 2 times u. So the tangent equation looks like this. Y equals minus 2 times u times x plus q. Moreover, since this tangent passes through point P, well, we know that P lies on the tangent, of course, so we can plug P into the function equation. So this leads to V equals minus 2 times u plus q. Solving for q leads to V plus 2 times u squared equals q. Now, of course, there are many unknowns in here, but we can do one thing. In fact, we know that P lies on T, but that's not the only thing. We also know that P lies on the graph of F. And this means V is given by plugging the x coordinate into the function equation of F. So V equals 3 minus u squared. Now, take this and plug it into this equation, and then we get a simpler equation for q. So 3 minus u squared plus 2 times u squared equals q. Simplifying leads to 3 plus u squared equals q. Putting everything together, we get the equation of the tangent. Y equals minus 2u times x plus 3 plus u squared. So this is the equation of the tangent. And you see here that's not that bad. We have just one unknown here, u, so that's not that bad. Now, let's continue with points Q and R. So let's start maybe with point Q. So Q lies on T, and moreover, if you consider the picture up here, well, Q is precisely here, so we know that the y-coordinate of Q is precisely the Q from the tangent equation. So Q, which we found here, is precisely the same thing as y1. And now you see here, we have established a relation between y1 and u. That's good. So next thing is point R. Well, of course, R lies on T as well. So we can plug the coordinates of R into our tangent equation, leading to 0 equals minus 2u times x1 plus 3 plus u2. And if you look at this, well, we can take this and solve it for x1. And that's it. So, and if you look at the whole thing now, well, here's the formula of the area containing x1 and y1. Here, we found a way to express y1 with the help of u. Here, a way to express x1 with the help of u. So we are done. We can take this and plug it into the area formula, and we will get a formula containing just one single unknown, namely u. So the area of the triangle is given by, this was our original formula, and now plugging in the things we've found, like this. Combining here like this. And this is the formula for the area. So this is going to be the function whose whose maximum we're going to find. Okay, so let's do that, and that's no longer difficult. So we take g of u, given by 3 plus u squared divided by 4u. We take derivative, okay? So here, there's a quotient here, so we need to apply the quotient rule. Moreover, up here, we are going to use the chain rule, so it's 2 times 3 plus u squared times the derivative of what is inside the bracket times the lower part minus the upper part times the derivative of the lower part, and the whole thing divided by the lower part squared. And this, of course, is going to be 0. So let's see here, we have 2 times 2 times 4, which is 16, then u times u is u squared, minus, and now I'm just going to solve for u, taking this on the other side. And now you see here I can divide by 3 plus u squared, which leads to 16u squared equals 12 plus 4u squared. This on the other side, 12u squared equals 12, dividing by 12 like this. So u is plus minus 1, but from the very beginning we've assumed u to be positive, so u is 1. So with this, we're basically done. Let's see, what was our task? Well, we want to find the coordinates of point P. We found the x-coordinate, the y-coordinate, well, we've seen above. This is the formula for the y-coordinate, so plugging in 1 leads to 2. And finally, we're asked to find the area of the triangle. Well, just plug the result we have here into the formula of the area, leading to 3 plus 1 squared divided by 4, which is 4. And that's the exercise.